Welcome to our lecture series on statistics. Today we'll be dealing with executing peer sample t-test in IBM SPSS. Peer sample t-test is one of the category of student t-test which is used to compare a group of data from the same sample. It is otherwise known as dependent t-test, or you can say related sample t-tests. By the end of this video, you should be able to understand the condition that necessitates the use of peer sample t-test. We should also be able to execute peer sample t-test in IBM SPSS. Also to be able to interpret your statistical result according to the APA style and make a reasonable conclusion. Now let us look at a particular situation, like the claim of the educationist theorizing about the transfer of knowledge, which they almost make it look as if that knowledge in one subject helps in the successful learning of another but related subject, meaning that a student who is good in mathematics is likely to be also good in physics, because these two subjects are related in terms of the calculations that are involved. So educational psychologists theorizing about this transfer of knowledge were fond of saying that knowledge in one subject can also be used to understand another subject, in as much as these two subjects are related. For a statistician, what you need to do is to collect data, a random sample data from a population, an homogeneous population. Let's take, for instance, like in mathematics and in physics, we have already randomly selected a sample of 20 students' scores in mathematics and in physics, which means here the student A, the first student here, 52, is scored 52 in mathematics, and whereas in physics he scored 48. Now the question is, will a student who scored this score here be able to also obtain a score like this in physics? A student who scored 48 in mathematics, will he be able to also score 50 in physics? So this is the claim of the transfer of knowledge theorists. So in order for us to subject this to test, we can now state our null hypothesis by saying that there is no significant difference of the students' scores in mathematics from the student scores in physics. So this condition now, because these samples they are related sample, and this score in mathematics also belongs to the same person as this score in physics. And we can see that we have 20 sample size. So we randomly selected these 20 students and collected their scores in mathematics and as well in physics, to see how differ will the scores are, or how close will they be. So in order to do, we have to now this condition will necessitate us to use peer sample t-test, or dependent sample t-test, or related sample t-test, as you want, which one you intend to measure. Now, to analyze our results using the peer sample t-test, we just have to import the data into the SPSS, as you have seen here. Then we also formatted our data, where we label the name as mathematics, and we also indicate the scores as scale, because achievement scores are scaled data. So the next thing to do is to go to analyze. When you click on analyze, this drop down appears. Then we go to compare means. Then we now go to peer sample t-test. Then click on peer sample t-test, and this box here appears. This box here appears. Then we transfer our variable, click on it, and transfer our variables one after the other to the paired variable box here, as you have seen here. Then we don't need anything much, except if we want to indicate our confidence level, which is already 95% by default. So just click continue, then we click on OK. Then our result is out. Now here is our results. The first box here, which is the peer sample statistics, shows the descriptive statistics of our variables, that is the student scores in mathematics and in physics. The mean score 57.1 in mathematics, and in physics is 56.0. The number of sample size is 20. Then the standard deviation is 12.6 for mathematics, while in physics it is 11.5. Then the standard error of mean 2.8 and 2.5 in mathematics and physics respectively. Then the next box here, the peer samples correlation, shows you the correlation between the student scores in mathematics and in physics. Then the correlation coefficient here is 0.979, and the p-value is less than 0.05. This correlation here shows you how close the scores of the students in mathematics and in physics are. So here it shows that there's a very high and positive correlation between the student scores in mathematics and in physics. However, this is not our peer sample result. This is not our peer sample t-test result. Our peer sample t-test result here is this here, paired sample test. Here we have the mean, then we have the standard deviation, we have the standard error of mean, the 95% confidence intervals of difference. Here is our test statistic result, 1.814. Then the degree of freedom is 19. Usually degree of freedom is calculated by subtracting 1 from the number of sample, which is n minus 1. Then here is our p-value. Here is our p-value, which is 0.086. So 0.086 is greater than 0.05. So for this reason, we have to now retain our null hypothesis. Retaining our null hypothesis means that we have to leave it as it is. It has already tells us that there is no significant difference between the student scores in mathematics and in physics. So this scores here show this p-value here I've already shows the probability at which this t-value will occur by chance or not by chance. So here the closeness of the scores did not occur by chance. So it was a clear closeness. For that reason, we have to now retain our null hypothesis and make our conclusions that students who actually score in mathematics high, they can also score higher in physics. Now reporting our findings, we can now say that there is no significant difference of the student scores in mathematics from the student scores in physics. Then in bracket, we also in parentheticals, then we bring out the empirical result by saying our t-test at degree of freedom 19 is equals to 1.814, and our probability value is greater than 0.05. So this is why we rejected our null hypothesis. We can also state our findings by saying that the student scores in mathematics did not significantly differ from their scores in physics. Now look at one thing here. We said did not significantly differ. Does that mean that there's no difference in the scores? There are differences in the scores actually, because we can see where a student score 50 in mathematics and score 48 in physics. These are some slight difference, but in statistics we are trying to look at how that difference will probably occur by chance or not by chance. Then secondly, we can see, whenever I still repeat it again as I've stated it in my previous video, that when you are bringing out your empirical test results in parenthetical style, as in this form, you must make sure that your letters, like the T letter here standing for the t-test, should be italicized. The same thing with the P standing for probability value will have to also be italicized. So therefore we can now conclude by saying that students who obtain higher scores marks or higher scores in mathematics also obtain higher scores in physics. And the same thing can be said for those who score lower in mathematics, they also score lower in physics. So this would invariably means that students who are good in mathematics can also be good in physics. And students who are poor in mathematics or who have poor background in mathematics will actually perform poorly in physics. Thank you very much for listening and have a wonderful day. I hope you have subscribed to our YouTube channel at Sajas Academy TV. If you have not done that, locate the subscribe button below and just tap it. Then make sure you give us a big thumbs up if actually you really like our video. And also, if you have any questions or contribution, make sure you drop it at the comment side below. Thank you very much and have a wonderful day.